All right, so let's practice De Morgan's law. So De Morgan's law says that not A or B is the same thing as not A and not B. So go ahead and prove it by working out the various parts of this and showing they're all the same. All right, so to do this, here's A and B. Let's first start out by calculating A or B. So A or B is going to be true when either A or B are true, so in these cases. And now let's show what not A or B is. So we'll invert that. So here's not A or B, and we see it's just true in this case, when neither A nor B are true. Now let's show this is the same as the other side here, which is not A and not B. So to do that, we'll first calculate not A and not B. Here's not A, you can see it's the opposite of A, and here's not B, you can see it's the opposite of B. Now we'll AND them together, and what we get for not A and not B is 1, 0, 0, 0, which is the same thing as we got for not A or B. So that shows that De Morgan's law is correct. Now let's go ahead and practice this Karnaugh map. So use a Karnaugh map to write down the logic function for C here. So to do this, we're going to take our inputs, and we put one of the inputs across the top and the other across the bottom, and we fill in the Karnaugh map here with the values here. So here A and B are both 0, so if A and B are 0, we see C is 0, so that's where we get the C is 1, so we get the 1 there. Now we go through and we circle the largest power of 2 block we can. So this is the block we have here, and this block is defined as being not A. So this is true when A is not true. So what we get from this is very quickly that our equation is C equals not A, which is not surprising if you look over here. C is 1 when A is 0, and C is 0 when A is 1. Let's try this on a larger Karnaugh map. So here's a more complicated formula here, and let's go ahead and fill out the Karnaugh map for this. So here we go, we filled in the Karnaugh map here, and we can just double check it. So when A and B are both 1, and carry in, C in is 1, we should have a 1 here. So here's A and B are both 1, and carry in is 1, and we get a 1. So those are the right values there. Now we want to circle the largest power of 2 blocks we can here. And what we see is we have 4 of them, but they're not in one total large block, so we can't circle them all at once. So we're going to go through and circle powers of 2. So here's 2 right here, and this equation here is true when carry in is 1, and it's true when A is 1. You can see that the first ones here are both true, so A is 1. So this is carry in and A. Here's another one here. This is true when A and B are both 1. So this can be A and B. And then finally we have our last one here, and this is going to be true when carry in is true and B is true. So you can see B is true here. So the output here is true when any of these are true, or an OR of all of those. So the carry out is this one, or that one, or that one. Now, why didn't we go through and select it this way, where we select one at a time? Well, we could certainly do that, but now look how complicated this is here. This is carry in and A and not B. And this one over here is carry in and not A and B. And so we end up with a much more complicated formula if we do that. This is the benefit of a Karnaugh map. If you select larger parts, you can get a more simplified formula.